Hey you guys, this is Mr. Sal. Thanks for watching. This is just a quick lesson on complex fractions. So don't forget to like, comment, and subscribe.
Now it sounds horrible, I mean, especially since we put in fractions. Rational expressions is just a different way to say fractions. And since we've already seen those rational expressions and division, none of this should be new here, okay? Except maybe the length of them, or we're looking at them a little bit differently. So, using multiplication by 1, yeah, that's great. I don't know. Reciprocate your second, and I think it's called the dividend, or the divisor. I think it's the dividend, not derivative though, definitely not. Yeah, reciprocate that. In fact, you may want to write it as a division problem, which may be helpful for you to see, just like that was the 5-1, right, where we did division. Again, it's just to make it more familiar for us, all right? Like this, okay? So if you have A divided by B all over C divided by D, write it as division, like you see right there, and then reciprocate the second part of that, C and D, so make it D over C, and change it to multiplication. So now you've got A times D, which is divided by B times C right there, okay? Now, of course, we'll be looking to factor these and see if there's anything we can cancel out, which I assume there will be. But that's really the way that I'm going to be doing it. I'm going to be changing it into old-fashioned division like this. In reality, we're just looking to change these to division problems, finding common denominators, simplifying. You can reciprocate and then multiply and then continue to simplify, all right? So the objective here really is to continue to simplify. So I'm going to write this as just a regular old-fashioned division problem and not a fraction, which hopefully will make this look a little bit easier for us. I've got that parentheses there just for, I don't know, formal purposes, even though we should know that it's divided by 1 divided by y minus 3 divided by x altogether, okay? So whether you include it there or not is okay, as long as you don't forget that it's also divided by the 3 divided by x. So this leading part here, I've already got a common denominator for those two, so I'm not too worried about that. What I am worried about is that set of parentheses. Right, I've got one denominator is y and one denominator is x, which is different, so I want them to be the same. So I need the y to have an x, but again, I need it to be a factor of 1. So I need to multiply it by the numerator as well. And then over here I've got an x, which is missing a y, so I can give it a y. But if I multiply that by a y, I need to multiply the numerator by y as well, so that I have a factor of 1. So this gives me something new. Well, now that I have those common denominators, I can combine those two terms into one fraction. And this is still division, but I don't need the parentheses anymore, even for notational purposes, because it's just one fraction. Well, now that I have that, I could reciprocate right now. Let's do that. And that changes this to multiplication now, which is good. We want that. And some of you may choose to start canceling stuff out now. But what I'm really looking at for me is this x squared minus 9y squared. That looks like the difference of squares right there. So in other words, my a is x. So I have a minus b and a plus b on that. And the b value for that would be 3y. So x minus 3y and x plus 3y. Of course, we didn't touch anything else. Now it may help us to see that x minus 3y in parentheses right there, just so we can see that it will cancel out, because all of this is simply multiplication, which allows us to look at this as one fraction. So when I'm canceling stuff out, I've got x minus 3y, which cancels out with x minus 3y. That becomes a factor of 1. I've got an x, which cancels out with this x, because it's a factor of 1. And then the y cancels out as well, because it's a factor of 1. And what are we left with? It looks like I'm left with just the x plus 3y in green there. That's it. All right. Nothing new here. I'm going to split this up so that it's a division problem. It may, I don't know, it may help us to see these, yeah, I guess that needs parentheses, as x over 1, just so we can see that denominators aren't different, okay? Otherwise, I've just seen that on tests where people just start combining stuff or ignoring that, that they need those common denominators, all right? So I'm going to start with my parentheses there on the left. I have a denominator of 7 and 1, so if I can multiply the 1 by 7, then I have common denominators of 7. And that gives me, over here, 9 over 7 minus 7x over 7. That's its own set of parentheses. And this is divided by, on the second set, I have a denominator of 5 and 1, so I'm going to multiply the 1 by 5. And that gives me 6/5 plus 5x over 5. Now again, it didn't change the value of those fractions, but it did change the way they look. Now that I have common denominators, we'll just write these out as single fractions. So 9 minus 7x over 7. This is all divided by 6 plus 5x over 5. Well, now that we have that, I'm going to reciprocate my second fraction there. And this allows me to make this one giant fraction once again. And this is multiplying each of these. So, I don't see anything I could factor out of those. So what I'm going to do is distribute my 5 back into this set of parentheses. And that distributes the 5, but I got to distribute the 7 in this other set of parentheses. 42 plus 35x. And just like we stated before, there's not really anything else to factor out there. That would be worth it, I guess. Nothing's going to cancel out as a factor of 1. So that's it. We'll just leave it like that. So we look at one like this. I mean, it looks different, right? But again, the concept is the same. If we have common denominators, then we can add and subtract our polynomials. And once we do that, we can make them single fractions, which allows us to change this instead of a division problem into a multiplication problem. So before I write this out as division, I want common denominators for both the numerator and denominator of both numerators and denominators. That may sound worse than it needs to be. But in any case, I'm just going to split this up into smaller problems, okay? I'm going to start with my full numerator, 5 over a plus 2 minus 1 over a minus 2. And I want common denominators here. So I've already got a plus 2 here. And if I multiply that by a minus 2, then it should help me get those common denominators. But it needs to be a factor of 1. So I multiply it by the numerator and denominator. You know, looking for alternatives, right? Well, now I need to multiply the green by this a plus 2 as well. But it's a factor of 1, so I multiply in the numerator also. Well, that gives me my single fraction here. And that right there really is just a difference of squares. But we're going to keep it like it is just to see if anything can cancel out, okay? So I'm going to distribute my 5 there, and this is considered a negative 1 because it's going to take that negative, the minus sign in front of it, okay? So that's 5a minus 10. Negative 1 times a is negative a. Negative 1 times 2 is negative 2. And I can combine my like terms here. That would give us 4a's minus 12 over a minus 2. and a plus 2. Well, it looks like I can factor out a 4 from my numerator there. So my final factored form of my numerator, 4 times a minus 3, all over a minus 2 and a plus 2. Just a minus 3. So that is my numerator, my new numerator over here, right? And I can write that in. 4 times a minus 3. Well, now we get to focus on the denominator, which is, kind of a separate problem there. And, well, once again, I've got this 2 plus a here, which is missing on the other side, so 2 plus a.
Real quick, how'd you...
And then I've got the 2 minus a, which also needs to be multiplied. I'm sorry, I forgot this other 2 plus a in the numerator, right? So that gives us common denominators. I won't skip the step this time. So now I've got in my denominator. And then I've got 2 minus a times 3, and then 6 times 2 plus a. And we'll distribute the 3 and the 6. And we'll just combine our like terms. So I've got my negative 3a's with my 6a's, which is 3a's. And then 6 plus 12 is a positive 18. Well, what color will I use? 3 times a plus 6 over. And now that I have that, that's my denominator from the original expression, right? So we'll write that out. 3 times a plus 6 all over 2 minus a times 2 plus a. Alright, that gives me a new, well, factored and simplified form of my numerator and denominator. And now I'm going to write this as old-fashioned division. Alright, yeah, now it's time to reciprocate this fraction here. Alright, looking at this new problem with multiplication, I see that there's not really anything that I could cancel out, but there is something they want you to be able to cancel out, okay? So I am going to change this into the difference of squares in the, the a minus 2 times a plus 2. I'm going to make that a squared minus 4. I like that idea better. Let's not do that garbage. Okay, that's good. Let's switch the 2 plus a in green there, right? In fact, we don't even really need to. We can just cancel them out right there. But there is a way we can cancel out the 2 minus a and the a minus 2. And that's by doing what you talked about before. By, in the green, if I factor out a negative 1 out of this, out of these two, then I get negative 1 times, now it would be a minus 2. Now I did flip those as well. So, I mean, to show all the steps, right? This is negative 1 times negative 2 plus a. But I've changed those around so that I have a minus 2, right? And, well, let's look at the rest of this actually first. With the canceled out a plus 2. And yeah, now we can see that this a minus 2 will cancel out with this one, because we changed it by factoring out the negative 1. So what I'm going to do is make that a negative 4, 4 times negative 1, and then multiply that by a minus 3, and divide it by 3 times a plus 6. Well, that was a little bit of work, but we got there. I mean, comparatively anyways. So once again, let's just focus on the numerator and denominator first, and get these to be individual fractions before we start reciprocating and stuff, okay? So I'm looking at 1 minus 4 over x squared, and 1 is really just 1 over 1. But I need common denominators before I start subtracting these. So I'm going to multiply my first term there by x squared. in both the numerator and denominator to make the common denominators of x squared. And now this gives me x squared over x squared minus 4 over x squared, which really just gives us one final fraction, x squared minus 4 over x squared. Now some of you notice that's the difference of squares right there, but it's not necessary that we do that yet, okay? I assume it will be later, but I just don't know. So that gives me a numerator of x squared minus 4 over x squared. Now let's work on that denominator stuff. Yeah, so the x squared means I'm missing an x from this left side here. So that ends up being 5x over x squared plus 10 over x squared. And that's going to equal 5x plus 10 over x squared. And that's my denominator up here. Well, let's write this as a division problem then. So I got x squared minus 4 over x squared divided by 5x plus 10. And again, this just allows us to reciprocate our second fraction there. So I'm reciprocating 5x plus 10 over x squared. But this now is multiplication because we're reciprocating, all right? And without any further simplification, at least, we can cancel out the x squareds. Maybe that helps us, maybe it doesn't, I don't know. It certainly simplifies the problem because now all we got is x squared minus 4 over 5x minus 10. So this is the time I would be looking to factor out now. I mean, you could have before, right?
5x plus 10.
Thank you. And we will need that. X squared minus 4, that's the difference of squares. So that becomes x minus 2 and times x plus 2. And then in the denominator, I can factor out a 5. So that'd be 5 times x plus 2, right? And that allows me to cancel out my x plus 2's, leaving me with just my x minus 2 over 5. Things aren't really going to change with 3 terms there in the numerator. I mean, we still need common denominators for all 3 terms, okay? And again, it may just be helpful to see that as 1 over 1. All right? So I have one term with a denominator of x and one term with a denominator of x squared. So that means that my middle term is missing an x. So I'm going to multiply the 7 by x. And my first term there is missing both x's. So x squareds. Now I'm going to skip that step just for time's sake. And that gives me x squared plus, that would be 7x now, plus 6 all over x squared. My other term, I have 1 over 1, and that is just missing the x right there. So in my denominator, I now have x plus 6 over x. And I will change this to a division problem. So I've got x squared plus 7x plus 6 over x squared. And I'm going to reciprocate this term to make this a multiplication problem. You know what, instead of making that x squared, just so we can see that, I'm going to make it x times x. Yeah, just right now, that allows me to cancel out at least one of the x's. Not only that, but I'm going to factor x squared plus 7x plus 6, because the 6, I can divide that up into 6 and 1. So x plus 6 times x plus 1. Then the other x canceled out, so this equals, just from the purple factorization, then I've got x times the green, x plus 6. And since we factor that out, the x plus 6's cancel. And all I'm left with is, it looks like this x plus 1 in red divided by x in purple. That'll do. In fact, this one is just like the one we just barely did. It's just written different. With the negative exponent thing, we have to go back to exponent rules for this. So my numerator, this is 4 plus 11 over x, because of that negative exponent. And then I'm subtracting this 3 over, now that's going to be x squared. Right, I mean that looks pretty familiar from that previous problem. 4 plus 13 over x plus 3 over x squared. I mean the denominator is a little different, but the idea is still the same. I'm going to need to multiply my 4 by x squared and the x by x, so that I have common denominators of x squared. Same idea with my denominator. That's 4 over 1.
I have a question.
Yeah, that's minus that 11x. Thank you. Okay. Well, I need that x squared with the 4 as well. And then I need another x in my middle term right there. I can put it on the right side. And now I have common denominators of x squared, which allows me to write that as a full fraction with a common denominator with x squared. So 4x squared plus 13x plus 3. Now I'm going to skip the division part of this and just simply reciprocate this, but I'm going to write it out completely, all right? Just for the sake of time. 4x squared minus 11x minus 3 over x squared. But I'm going to change this right now to multiplication and reciprocate my denominator here. So that would be x squared over 4x squared plus 13x plus 3. And from here we can see the x squareds cancel, which is pretty nice. But I've got this new set of trinomials that we should make an attempt to see if we can factor those out. So let's look at factoring the red 4x squared minus 11x minus 3. So I've got 4 times negative 3, which is negative 12. Two factors of negative 12 that add to negative 11, negative 12, and positive 1. So this factors out, splits up into negative 12x and positive 1x. Of course, we got the minus 3 and the 4x squared. And from here I can factor out, looks like a 4x, which makes that x minus 3. And in that second set I can factor out a 1, which makes that x minus 3. So in my numerator now, and I'm going to factor that out, x minus 3 times 4x plus 1. In my denominator, 4x squared plus 13x plus 3, same idea. 4 times 3 is 12. Two factors that add up to 13, 12 and 1. So I'm going to split the 13x up into 12x and 1x plus 3, and then we got the 4x squared. Well, it looks pretty much the same, slightly different. I'll factor out 4x, which leaves me with x plus 3. And I'll factor out a 1, which leaves me with x plus 3. And sure enough, this allows us to cancel out as a factor of 1, 4x plus 1. Right, these two cancel out. And all we're left with is x minus 3 divided by x plus 3. Well, nothing unusual here. Looking for common denominators in the numerator and denominator. I'm going to start with my numerator. So I'm going to multiply my x minus 3 to the right side, but as a factor of 1. And I'm going to multiply x minus 4 to the left side. Put it right here. And yeah, we need these in parentheses as well. So x minus 4 there as well. Okay, well that gives us common denominators, which is good. Just to save time, I guess we could use FOIL, whatever. So I got x squared minus 4x plus 1x minus 4. I mean, I don't really like this method, but whatever. And in between those, we had minus, so this is going to be minus in parentheses. Yeah. X squared minus 3x plus 5x minus 15. And we can simplify these, the green and the blue there. So that is, okay, well that's minus. So, I mean, we could subtract these. I'm going to distribute this as -1 into this set of parentheses. All right, and combining my like terms, I got the x squareds that cancel out. Negative 3x and negative 2x gives me negative 5x's. And then we got negative 4 and positive 15 is positive 11. So that's pretty well simplified for just the numerator part of that. Yeah, it was some work. Okay, well that brings us to the denominator. And yeah, we gotta get the denominators to be the same, so I'm going to multiply x minus 4 in the right fraction. X minus 4. And we'll multiply x minus 3 as well to the right. So x minus 3, x minus 3, so it's a factor of 1. And we have our common denominators. Yeah, let's go ahead and FOIL this one out. So x squared plus 4x minus 3x minus 12. And then we're going to add that to this other one, x squared minus 4x plus 3x minus 12. And we can just start combining all like terms right now, for that matter. Yeah. So the x squareds, oh, I got two of them. This x squared and that one. So I got 2x squareds. 4x minus 3x is 1x, minus 4x, negative 3x, plus 3x is 0. Actually, that's pretty nice. Then we got negative 12 plus negative 12, that's negative 24. And out of my numerator, I can factor out a 2 just to see what happens. 2, so that'd be x squared minus 12. All over x minus 3 times x minus 4. Well, from right here, we may be looking at the x squared minus 12 as the difference of squares, but 12 is not a perfect square, so we're not going to worry about that in terms of factoring it out. All right, just like I did on that last problem, just for the sake of time, I'm going to reciprocate my denominator here and change this into a multiplication problem. And at this point, we can see the x minus 3's cancel, the x minus 4 cancel each other out, which leaves us with negative 5x plus 11 all over 2 times x squared minus 12. And we may be looking to factor anything out at this point. However, I don't see anything that factoring would help us out in this case. So that is just going to be our final answer right there.